For decades, we believed we understood Megalodon. That belief is wrong, and the real mistake is far more disturbing than most people realize. Because Megalodon did not disappear the way we were told. It vanished for a reason that still controls the ocean today. If Megalodon truly failed because it was too big, then nature made a mistake. But nature does not make mistakes. It removes what does not fit and preserves what does. So the real question is not what happened to Megalodon. The real question is why we were never meant to understand it. When people hear the name Megalodon, the same image appears almost instantly: a massive shark, endless aggression, a monster with no limits. Movies, thumbnails, and dramatic stories trained us to see it this way. Over time, that image felt so familiar that we stopped questioning it. Fear replaced understanding. Megalodon became known only for its size and its teeth, the largest shark, the strongest bite, the ultimate predator. And when it disappeared, the explanation felt easy. It was too big, too extreme, too powerful for a changing world. That explanation sounded logical. It was also incomplete. Nature does not allow unstable designs to dominate for millions of years. Megalodon existed for more than 15 million years. That alone tells us something important. A creature does not survive that long by accident. It survives because its body, behavior, and environment work together in balance. Megalodon was not a short-lived experiment. It was a long-term success. So why did we treat it like a failure? One reason is the evidence we focused on. Scientists never discovered a complete Megalodon skeleton. Sharks are made mostly of cartilage, and cartilage rarely fossilizes. What survived were teeth and parts of the spine. Those pieces were dramatic, easy to display, and easy to misunderstand. Teeth became the story. Huge teeth suggested non-stop violence. Massive jaws suggested endless hunger. Slowly, Megalodon was reduced to a weapon instead of a living system. But teeth only show how an animal eats. They do not explain how it moves, how it saves energy, or how it survives for millions of years. By focusing on the most frightening evidence, we ignored the most important questions. Another major mistake came from comparison. Megalodon was constantly compared to the modern great white shark. The teeth looked similar, the shape seemed familiar. So we assumed Megalodon was simply a much larger version of a shark we already understood, but nature does not scale creatures that way. A body that works at one size does not automatically work at another. Making something bigger changes how it moves, how much energy it needs, and how it survives. By forcing Megalodon into the shape of a modern shark, we stopped asking whether it might have lived differently. That assumption quietly broke our understanding. We also removed Megalodon from its world. Megalodon did not live in today's oceans. It lived in a warmer planet, with higher sea levels and more large marine animals. Coastal waters were different, food systems were different. The ocean itself followed different rules. Megalodon was not too large for that world. It was built for it. When we judge Megalodon by modern conditions, the story collapses. It begins to look unstable, extreme, unsustainable. But that judgment ignores the environment that shaped it. The real question is not why Megalodon was so big. The real question is why being that big worked for so long. Once we ask that, the picture changes completely. Megalodon stops looking like a failed monster and starts looking like a carefully adapted predator, one that belonged to a specific system, under specific conditions, for a very long time. And when those conditions began to change, the outcome was never going to be simple. Megalodon did not disappear because it was weak. It did not disappear because it was slow. It did not disappear because it was poorly designed. It disappeared because the rules of survival changed. And once you accept that, one uncomfortable truth becomes clear. We were never really asking who Megalodon was. We were only asking how terrifying it looked. Because once you understand how Megalodon's body actually worked, you'll realize size was never the real problem at all. For a long time, our understanding of Megalodon was built on incomplete evidence, not because scientists were careless, but because nature did not preserve the full picture. Unlike dinosaurs, Megalodon never left behind a complete skeleton. Its body was made mostly of cartilage, and cartilage almost never fossilizes. What survived were teeth and parts of the spine. Those fragments shaped everything we thought we knew. Megalodon teeth are massive, sharp, and impossible to ignore. Some are larger than a human hand. When these teeth were first discovered, one conclusion felt obvious. A creature with teeth like this must have been violent, aggressive, and constantly hunting. Over time, the teeth became the identity of the animal. That was the first major mistake. Teeth can tell us how an animal eats, but they cannot explain how it lives. They do not show how it moves, how much energy it uses, or how it survives over long periods of time. By focusing almost entirely on teeth, we ignored the systems that actually keep a species alive. Early reconstructions made this problem worse. Scientists and artists took the body of a modern great white shark and scaled it up. Same shape, same proportions, just much bigger. This image spread quickly because it was easy to understand. A familiar predator, only larger and more dangerous. But nature does not work like a copy machine. When researchers later tested this idea, they found serious problems. A great white body stretched to Megalodon's size would be inefficient. The muscles would struggle to support the mass. The energy cost of movement would be extreme. A body like that would burn energy too quickly to survive for millions of years. That kind of design does not last. This forced scientists to rethink the body of Megalodon. Instead of asking how big it was, they began asking how a creature that large could function at all. The answers pointed toward a very different body structure. Megalodon was likely broader and heavier than early images suggested. Its body was probably built for stability, not constant speed. In water, stability reduces energy loss. It allows a massive animal to move smoothly without fighting the ocean at every moment. Efficiency matters more than speed. Large animals today show the same pattern. Whales are enormous, yet they move with controlled power, not frantic motion. Their size helps them maintain momentum instead of wasting energy. Megalodon likely benefited from the same physics. Movement is another area we misunderstood. Size does not automatically mean slowness. In water, a large, powerful body can generate strong, controlled motion. Megalodon did not need to chase constantly. It needed to position itself correctly and strike at the right moment. Its spine supports this idea. Fossilized vertebrae from Megalodon show thick, strong structures. These suggest powerful muscles capable of controlled force. This was not a clumsy animal dragging itself through the ocean. It was a predator built for deliberate movement. Energy use is where the story becomes even more interesting. For years, people assumed Megalodon needed to eat constantly just to survive. But newer research suggests that Megalodon may have had advanced metabolic traits. Some modern sharks can keep parts of their body warmer than the surrounding water. This improves muscle performance and efficiency. Evidence suggests Megalodon may have had similar abilities. This does not mean it was fully warm-blooded like a whale, but even partial temperature control would reduce energy loss. That means fewer hunts were needed, fewer risks, greater survival. This detail changes how we should imagine Megalodon's behavior. A predator that manages energy well is not desperate. It does not attack everything it sees. It waits. It observes. It chooses moments with the highest chance of success. That kind of behavior fits a species that survived for millions of years. When all these pieces come together, the picture changes completely. Megalodon was not a giant mistake. It was not an unstable experiment. Its body was carefully suited to its role, which leads to an uncomfortable conclusion. If Megalodon's body was efficient, balanced, and powerful, then its disappearance cannot be blamed on physical failure. Creatures with flawed bodies fail quickly. Megalodon did not fail quickly. It thrived. So the real question shifts. Instead of asking what was wrong with Megalodon, we are forced to ask what changed around it. Because when a perfectly adapted body stops working, the problem is rarely the body itself. It is the world it depends on. Because once you understand how Megalodon's body truly worked, the real mystery becomes how a system this perfect could ever collapse. To truly understand Megalodon, we have to forget the idea of constant chaos. The strongest predators do not survive by attacking everything they see. They survive by controlling their energy, choosing their moments, and avoiding unnecessary risk. Megalodon lived by those rules. Megalodon was not a creature of non-stop violence. It was a creature of control. Its survival depended on doing as little as possible while gaining as much as possible from each hunt. This is how large predators stay alive for millions of years. Its primary food source was large marine animals, especially early whales and other ocean mammals. These animals were rich in fat, which meant enormous energy from a single successful hunt. One kill could support Megalodon for a long time. This reduced how often it needed to hunt and lowered the risk of injury. That detail changes everything. A predator that feeds on large prey does not chase constantly. It waits. It observes movement patterns. It chooses moments when prey is weak, injured, or distracted. Megalodon's massive jaws and powerful bite were designed to end encounters quickly, not to drag them out. Fossil evidence supports this controlled hunting style. Ancient whale bones show deep bite marks that match megalodon teeth. Some of these bones also show signs of healing. This means some whales survived attacks and escaped. That tells us Megalodon was part of a balanced ecosystem, not a force that destroyed everything around it. Balance is survival. If Megalodon had wiped out its food sources, it would have disappeared quickly. Instead, it thrived for millions of years. That only happens when predator and prey exist in long-term balance. Location played a critical role in how Megalodon lived. Fossils are most commonly found near ancient coastlines, not in the deep open ocean. This suggests Megalodon preferred warm, shallow waters where large prey gathered and hunting was efficient. These coastal areas were important for another reason. Scientists believe Megalodon used nursery zones, similar to modern sharks. These were protected coastal waters where young megalodons could grow with fewer threats. Smaller predators were less dangerous here, and food was easier to find. This increased survival rates and helped the species continue across generations. A species that protects its young is not reckless, it is strategic. Megalodon also appears to have been a long-distance traveler. Evidence suggests it migrated across oceans, following warm currents and shifting prey. As seasons changed, Megalodon moved with them. This behavior allowed it to conserve energy and remain close to reliable food sources. This was not random movement, it was calculated survival. Another key part of Megalodon's life was temperature. For a long time, people assumed Megalodon was completely cold-blooded, like many modern fish. But studies of shark physiology suggest a more complex picture. Some modern sharks can keep parts of their body warmer than the surrounding water. This improves muscle performance, reaction speed, and efficiency. Evidence suggests Megalodon may have had similar regional temperature control, not fully warm-blooded, not fully cold-blooded. This balance gave Megalodon a major advantage. It could hunt effectively without burning energy like a mammal. It could remain powerful without needing constant food. This efficiency helped it dominate warm oceans for millions of years. Every part of Megalodon's life shows careful balance. Its prey choices reduced risk, its hunting style conserved energy, its habitat supported growth, its body matched its environment. Nothing about this system was accidental, which makes the next part of the story unavoidable. Systems like this do not collapse suddenly, they weaken slowly. Pressure builds over time, small changes accumulate. At first, survival continues as normal. Then one part fails, then another. Megalodon did not wake up one day and fail to survive. The world around it began to change. Water temperatures shifted, prey migration patterns changed, coastal environments transformed. Each change alone was manageable. Together, they were not. Megalodon was perfectly adapted to a specific world. When that world began to disappear, its greatest strengths became limitations. Its size required energy the ocean could no longer provide. Its specialization left little room to adapt. This leads to one uncomfortable truth. Megalodon did not disappear because it lived the wrong way. It disappeared because it lived the right way for a world that no longer existed. And when the ocean changed its rules, Megalodon discovered that perfect adaptation can become a deadly trap. Megalodon did not disappear because it suddenly became weak. It disappeared because the ocean it depended on slowly changed in ways it could not escape. This change did not happen in one moment. It happened over thousands of years, quietly reshaping the rules of survival. The first major shift was temperature. For most of Megalodon's existence, Earth's oceans were warmer than they are today. Warm water supported large marine life and allowed massive predators to function efficiently. But as the planet entered cooling phases and ice ages began to form, ocean temperatures slowly dropped. This cooling created a serious problem. Megalodon was adapted for warm environments. Cooler water increased energy demands. Muscles required more effort to function. Movement became less efficient. Even if Megalodon remained powerful, simply existing now cost more energy than before. At the same time, Megalodon's prey began to move. Large marine mammals, especially whales, started changing their migration patterns. As oceans cooled, many whales moved toward colder regions where new food sources appeared. Smaller predators could follow these changes easily. Megalodon could not. Its size and design worked best in warmer waters. As prey moved away from these regions, food became harder to find. For a predator that relied on large, energy-rich prey, this was dangerous. Megalodon could not simply switch to smaller animals. Its body and hunting strategy were built for big targets. Then came another critical change. Sea levels began to fall as ice formed at the poles. Shallow coastal areas slowly disappeared. These areas were not just feeding zones. They were nursery grounds where young megalodons could grow with less risk. When these nursery areas vanished, the impact was severe. Young megalodons were exposed to greater danger from other predators. Survival rates dropped. Fewer juveniles reached adulthood. Over time, the population began to thin, not because adults stopped hunting, but because fewer young replaced them. Extinction often begins this way. While megalodon struggled, other predators adapted. Smaller sharks, including early great white sharks, required less food and adjusted more easily to cooler waters. They could hunt a wider range of prey and survive with fewer resources. These predators began filling ecological roles Megalodon once controlled. Even more important were early orca-like predators. These animals hunted in groups. They shared strategies, they communicated. Group hunting allowed them to take down large prey more efficiently and adapt quickly to changing conditions. Megalodon hunted alone. That difference mattered. Group hunters can respond to environmental change faster than solitary predators. They can shift behavior, target new prey, and survive under pressure. Megalodon's strength lay in its size, not flexibility. Now multiple pressures hit at once. Food sources declined, nursery habitats disappeared, competition increased, energy costs rose. Each problem alone might have been survivable. Together, they created a trap. This is where many people misunderstand extinction. They imagine a dramatic ending, a final battle, a sudden collapse. But extinction rarely looks like that. More often, it looks like silence. Fewer sightings, longer gaps between successful hunts, lower birth rates over generations. Until one day, the system no longer works. Megalodon did not vanish overnight. It faded as the ocean slowly stopped supporting it. The ocean did not attack Megalodon. It did something far more powerful. It changed. And when the environment changes faster than a species can adapt, even the most dominant predator loses its place. Megalodon's size, once an advantage, became a burden. Its specialization, once perfect, left no room to adjust. This is the hardest truth to accept. Megalodon did everything right for millions of years. It lived exactly as it was designed to live. It dominated its world. But when that world moved on, Megalodon could not move with it. And yet, even after all this time, one idea refuses to disappear from the human mind. If Megalodon truly vanished, why does its mystery still feel unfinished? Because when something this powerful disappears without witnesses, the question refuses to stay buried. Even after everything science has uncovered, one question still refuses to disappear. People ask it again and again in comments, videos, and discussions around the world. Is Megalodon really gone, or could it still be hiding somewhere deep in the ocean? This question survives because the ocean feels endless. It is dark, deep, and largely unexplored. When people hear that most of the ocean has never been seen by humans, they imagine space for secrets. And a creature as massive as Megalodon feels too powerful to simply vanish without leaving a dramatic ending. Emotionally, the idea makes sense. But science does not work on emotion. It works on patterns, evidence, and impact. And when we look at those things carefully, the picture becomes much clearer. If Megalodon were still alive today, the ocean would not look the way it does now. A predator of that size would need enormous amounts of food. It would hunt large marine mammals regularly. That kind of pressure would leave visible signs in whale populations, migration routes, and ecosystems. We do not see those signs. There are no fresh Megalodon teeth, no recent bones, no DNA, no verified sightings that hold up under investigation. For a creature that large, the absence of evidence is not a mystery. It is evidence itself. Large animals cannot exist quietly. Even in the deep ocean, massive predators affect everything around them. They leave scars, remains, and patterns. Scientists track whale injuries, population changes, and ocean behavior very closely. Nothing points to a living Megalodon. This is why the scientific community agrees that Megalodon is extinct. Not because scientists want to close the story, but because every reliable signal points in the same direction. So why does the question remain? Because Megalodon represents something deeper than biology. It represents a time when nature allowed giants to exist, a world where size, power, and dominance shaped survival. Letting go of Megalodon feels like letting go of that world. And that is uncomfortable. Megalodon did not disappear because humans hunted it. It did not disappear because it was outsmarted. It did not disappear because it became weak. It disappeared because the system that supported it collapsed. Climate changed, prey moved, habitats vanished, competition increased. When these changes combined, the balance Megalodon depended on was lost. And once that balance broke, even perfection could not save it. This is the part we often miss. Megalodon was not a failure of evolution. It was a success that lasted millions of years. But evolution does not protect success forever. It protects adaptability. When adaptability is no longer possible, extinction follows. Nature does not care how powerful something once was. It cares how well it fits the present. That is why Megalodon's story still matters today. The same forces that erased it are shaping life on Earth right now. Climate shifts, changing food chains, and shrinking habitats are not ancient problems. They are happening all around us. Megalodon is not a warning about monsters. It is a lesson about systems. We misunderstood Megalodon because we wanted a dramatic explanation. We wanted a final battle, a single cause, a clean ending. But extinction is rarely dramatic. It is usually quiet, slow, and unnoticed until it is complete. One generation struggles, the next becomes smaller, the next never arrives. That is how giants disappear. So when people ask if Megalodon could still be alive, the honest answer is not exciting, but it is powerful. Megalodon belongs to a world that no longer exists. And when that world disappeared, so did it. Not with a roar, not with a final attack, but with silence. That silence is why we kept asking the wrong questions. And once we finally ask the right ones, the truth becomes clear. We never misunderstood Megalodon because it vanished in the ocean. We misunderstood it because we were never looking at the system that made it possible.